Right. Okay, so voltmeters need to be connected over a battery. And when they're connected over the battery, let's just repeat what it says. What is that voltmeter measuring? How many joules, or let's just say volts. How many volts of energy are available to move electricity through the circuit? Now, Jock says we can also put a voltmeter over a resistor. Does a resistor provide electricity, energy? So what would that voltmeter be reading if it could speak? Well, how much did that battery have available? This one would be saying, how much would the battery use over here? Because do you agree, a voltmeter can read two things. It can either read how much energy is provided, is available, or it can measure how much energy is being used. Over here, when you put a voltmeter over a battery, it's measuring how much energy is available to move electricity. When you put a voltmeter over a resistor, resistors don't make energy available, they use energy. It would measure how much of the battery's 12 volts is being used to get the current to flow through that resistor. So it would be saying, of the battery's 12 volts, how much would be used to move the electricity through that resistor? All 12? Half of it? Some of it? You don't know? All 12 volts are being used to move electricity through this resistor. Okay, so let's just read what the 2 voltmeters would be saying. Let's just stop, because this is critically important and pupils often get this wrong. Excuse me. We said there are 2 places where you can put a voltmeter. What are those 2 places? Over a battery of cells, or even over just one cell, and over a resistor. Could I put it over a lamp? Yes, a lamp is a resistor. Could I put it over an ammeter? An ammeter, we said, has got practically 0 resistance, so it's stupid. It would be the same as putting a voltmeter over there, over a bit of copper wire. Okay? It would be pretty close to 0, yes. So, what is this voltmeter reading? How much of energy is available to do what with? To move electricity around the circuit. When you put a voltmeter over a resistor, it's not measuring how much energy is available, because resistors don't have energy available. What do resistors do? They chew up energy, okay? It's saying, of the battery's 12 volts, how many in this case has been used here? All 12 is being used to get the electricity to move through here. Because the rest of the circuit's got practically no resistance, it doesn't need to spend any of its energy elsewhere. Let's have a look at another setup. I can take this off the board now. Right, let's take this same setup, closed circuit, volts, and let's make this 2 ohms. Let's make this 2 ohms to start off with. Okay, and 2 ohms. How many places could I put a voltmeter in that circuit? Where could I put them? One would be put over there. Well, let's call that voltmeter number 1. Where else could I put a voltmeter? I could put it there, voltmeter number 2. Where else? Over the other resistor. Voltmeter number 3. There's actually another place I can put it. Over both. Voltmeter number 4. Right, could anyone tell me what would voltmeter number 1 be saying if it could speak? This battery has 12 volts of energy available to move electricity through the whole circuit. Okay. As a matter of interest, where is it going to have to spend those 12 volts? It's going to have to spend energy here and energy there. Is it going to have to spend energy here? No. Practically no energy anywhere else, just there and there. Tell me about the speed of the current in this circuit. Where will it flow faster? Before the resistors or after the resistors? Is it the same everywhere? Yes. The speed of the current strength, is the same everywhere in a series circuit. Do I have any parallel branches here besides the meters? No. So everywhere in a series circuit, the current is the same. So where is the battery going to have to spend more of its 12 volts? There or there? Because remember, the current there is the same as the current there. Current's the same everywhere. Where is it going to have to spend more of its voltage? It's going to spend the same everywhere. So how much will it spend here? And it's only got 12 volts available. You can't spend 12 and 12. That's 24 volts. So it can only spend 6 volts. Okay? This reading is going to be 6 volts, and this one's going to be. If it could speak, what would it be saying? Of the batteries, 12 volts, 6 volts are being spent here, or being used here to get current moving through this resistor. Okay, so let's put it in. Of the batteries, 12 volts, 6 volts are being used to move electricity through this resistor. Happy with that? What would it be saying? Yeah. Exactly the same thing. Can I just put ditto? Okay. What would this one be reading? So this would also be reading 6 volts. What would this one be reading? You say 12 volts. What would it be saying if it could speak? Of the batteries, 12 volts. How much is it using between that point and that point? All 12 volts are being used to do what? To move electricity through what? Through these two resistors. Happy with that? Okay. Right, so you get an idea of how it works. So the battery's got 12 volts available. What do you notice about the battery and its 12 volts? What did we say this one would say? This would read? What would it be saying if it could speak? This battery has volts available to move electricity through the circuit. How much is it using here? 6 of the 12, yeah? 6 of the 12. Between that point and that point, all 12. Fantastic. What do you notice about the battery and its volts? It always uses all of them. It never holds any back. It never says, hold on. I'll only use 10, because just in case this guy goes and shoves another resistor in here, then I need some spare. Because what happens if I do put another resistor in there? Let's say I put another 2 ohms in there. What will it now do? It'll have to recalculate and say, sorry, I can't give you 6 volts anymore, I can only give you 4. So if it's only getting 4 volts for each resistor, tell me about the speed of the current. It hasn't got as much energy for each resistor, so it's going to flow slower. And what did we say will happen when you add another resistor? It slows the current down, isn't it? So that's actually why. Because the battery now can't say 6 volts for you, 6 volts for you. It's got to say, sorry, we're going to redivide only 4 volts, 4 volts, 4 volts. The electricity is still the same everywhere, but it's flowing slower. Yes?
What would happen if you had a
Different resistors.
no, what would the voltmeter over the start have?
It would save 12 volts.
What is it, 12?
12 volts is, what does it read? This battery has 12 volts of energy.
If you had to move the voltmeter somewhere else, but it still reads 12 volts.
Yeah, no. It becomes pretty difficult, okay? Well, what's the difference between this voltmeter here and this one here? This one's not over resistors. It's actually over the battery. Agree, it's the same thing. We're just moving the terminals along the copper wire. We're not jumping it across any new appliances or new circuit components. So in fact, this voltmeter and that voltmeter are actually in the same place. They're over the same thing.
So then even if the two wires are close together on that corner, that's
There or there. Let's say this one wasn't there and you put the two wires there. You could either look at it, and say this voltmeter is reading the battery strength, or it's reading how much has been used on the circuit. Okay. Right. Any questions? Let's take it half a step further. Same 12 volt battery. And we go back to two resistors. Happy? And this is a 2 ohm resistor and this is a 1 ohm resistor. Tell me in which circuit, left or right, will the current flow faster? What will the current be there? This was 12 volts. 4 amps. How did you get it? V over 3. 12 over 3 is 4 amperes. This 12 over, take this one out now. Let's go back to 4. 12 over 4 is 3 amperes. Okay. So we can just say I equals 12 over 4 equals 3 amps. Over here, I equals 12 over 3 equals 4 amps. Right. What would this voltmeter here, V1, be reading? Okay. Let's put voltmeter V2 in there and voltmeter V3 in there. What would the reading on each voltmeter be? 8 and 4. Or would it be 6 and 6? Which is the tougher resistor to get electricity moving through? 2 ohms. How many times tougher than this one? Twice as tough. What do you know about the speed of the current everywhere in a series circuit? It's got to be the same. So this battery knows your job is to keep the current moving the same speed everywhere. How many joules have you got available? How many volts have you got available? 12 volts. So where are you going to spend your 12 volts? You're going to spend some here and you're going to spend some here. Which one are you going to give more to? Why are you going to give more there? That's a tougher one. It's a steeper hill, but you've got to keep that bicycle moving the same speed as on the slack hill. Okay, where's a cyclist going to spend more energy if he's got to keep his speed the same, but he's got to get over that hill or this hill? Going to spend more. How much? If this is twice as steep as this, twice as much energy is there. So this battery's got to spend twice as much energy there as there. Who of you can divide 12 up so the one gets twice as much as the other? This is going to get 8 volts. This is going to get 4 volts. Do they still add up to 12? Yes. Okay, they must always go back to 12 because the battery always uses all of its energy. It can't only use 10. And it certainly can't use more than 12. Okay? So, what would that voltmeter be saying if it could speak? Of the batteries, 12 volts. 8 volts has been used to move current this resistor. At what speed is the current going through here? 4 amps. What would it be saying over here? Of the battery's 12 volts, 4 volts is being used to move current through here at 4 amps. Okay. If you weren't sure of being able to work that out, you'd simply say, what's your formula for voltage? V equals I times R. What is the current that's flowing through here? 4. What's that resistance? What's the voltage here? I times R. What is the current here? It's the same, 4. What's the resistance there? Electricity is easy, people. It really is easy stuff. It's not complicated. Okay, let's read through those notes that you've got on page 11. It's all in your notes, Giovanna. Okay, right. Let's go through it. You may want a highlighter. Until now, you've been taught that voltmeters can only be connected over a battery to measure the EMF. That's the battery strength. Up until grade 10, that's basically the only place you put voltmeters, over batteries. So, for example, there in number 13, could anyone tell me what the voltage of that battery must be? Could you do the calculation there? V equals, what's your formula for voltage? V equals IR. What is I there? It's given to you. 3, what is R? 2 gives you an answer of 6 volts. So what would that voltmeter be reading? This battery has 6 volts, in other words, joules per coulomb. Remember, I said a volt is a joule per coulomb. Okay. You can either talk about a battery having 6 volts or 6 joules per coulomb. I just tend to talk about 6 volts of energy. It's not strictly speaking correct. It has 6 volts of energy, 6 joules per coulomb, available to move charge around the circuit. Okay, that's old news. Let's read the next paragraph. However, voltmeters can also be connected over resistances. In these cases, they measure how much of the battery's energy is being used to move charge through that resistor. So there I've shown you what's the voltage of the battery? 12 volts. What would V1 be reading? 12 volts. V2 of the battery's 12 volts, how many volts are being used to move current through the 4 ohm resistor? Quickly do the calculations and fill in the dialog bubbles, please. Do the calculations and fill in the dialog bubbles. In fact, don't do the calculations. Let's just stop where we are. Let's just have a look here. Let's say that was 4 ohms and that was 2 ohms. What was it before? This was 2 and 1. What was my total resistance? 2 and 1 was 3. Okay, what have I made it now? 4 and 2. I've doubled my resistance from 3 to 6. What's that going to do to my current? It's going to halve it. Do you all agree? But let's not even look at that. Let's just say how many volts have I got available? 12. Where's that got to be spent? There and there. Which one must get more? 4. How many times more than this one? Twice as much. Divide 12 up so that this one gets twice as much as that. It's still going to be 8 and 4. Right. If this was 6 volts, what's it going to be? 4 and 2. Does that add up to 6? Yes. Is this one getting twice as much? 4 as that one? 2? Yes. Okay. Divide up 9 volts, so this one gets twice as much as that. Six and 3. Does it add up to 9 volts? Yes. Okay, do that example in your book, please. I want the one on page 11 to be completed. I'll give you plenty of more examples. Don't worry, Dylan. Don't worry. Okay, right, you all finished? What does V2 read, please? 8 volts. V3, 4 volts. Okay, can I hand out page 12? Sorry? Oh, sorry. Voltage over resistors. Sorry, I was going to explain why I made the line under voltage longer than just the word voltage. The heading should have been voltage over . Right, let's read page 12. Is anyone absent? You sure? Why have I got an extra page? You got 14. Yeah, I only made 14 copies. Okay. Right. Okay, thank you. Let's stop talking. Page 12. Note the following from the previous example. 1. The voltages in the circuit. In other words, when... Yes? Whose is this? Could everyone check that they've got page 12? No one got a page 13 or... Okay. Right. Let's read through page 12. The voltages in the circuit, in other words, voltage 2 and voltage 3. These are the voltages in the circuit. This is the voltage over the battery. Okay? The voltages in the circuit, V2 and V3, always equal the voltage of the battery, V1. I.e. the battery always uses all of its voltage. It doesn't use more than it's got. It can't. And it doesn't hold any voltage back. Right. Number 2. In that previous example, the 4 ohm resistor, this one, is twice the resistance of the 2 ohm resistor. So therefore it must get twice as much of the battery's energy compared to that one. So if we're to, in this case, take 9 volts and divide 9 volts up so that this one gets twice as much as this would get 6 volts and this would get 3 volts. In the previous example in your book, I think it gives 8 and 4. Right. And therefore, point number 3 there, we say that resistors in series are, what have they divided up amongst themselves? They are voltage dividers. You probably got taught this in grade 9, but didn't quite understand what it meant. But resistors, when they're in series, they say, right, that's the battery's voltage, let's divide it up amongst ourselves. I'm getting twice as much as you're getting. Okay, they are voltage dividers. I'd like you to do number 15 now, please, quickly. It's easy. It's really simple. You can do it without doing a calculation. Number 15. Right, who's got an answer for me for number 15? We'll have a look at number 15. What is the voltage that the battery has available, Giovanna? No, in number 15. What? Have a look. How much has the battery got available? Oh, I like this thing's a slow delayed. Look at the pencil moving. Okay, right. How much voltage has that battery got available? 12. How much is it spending there? 9. How much has it got left over for there? 3. Has it got to spend voltage anywhere else? So it's got to spend 3 there. So V3 will read 3 volts. All agree? Would you do number 16, please? As I say, these things you can just do by looking at them. They're simple, they're straightforward, they're not complicated at all. Okay, Pauline. How many resistors have you got in that circuit there in number 16? 2. There we go, there and there. How much is spent at that resistor that I'm pointing to now? 7, and the other one? And therefore, what must the voltage of the battery be? 15. Simple, straightforward. Just by looking at that, Jonathan, which of these 2 resistors, the one there on the left or the one on the right, which one is the bigger resistor? The one on the right. Good. Number 17. Do that one, please. A little bit more complex. The first thing I want to point out to you in number 17, where's the voltmeter being connected, Jonathan? If you just have a look at number 17, all of you, let's just have a look here on the board. Have a look here. This voltmeter, where is it connected? Is it connected over the battery? Yes, that's exactly, and same here. That voltmeter is exactly the same as that. I can just take that wire and I can slide it up to there. It doesn't make any difference because I'm not moving it over any components, am I? And I can take that clip point there and move it to there and then just bend the voltmeter up. It's just on wires. It's exactly the same as that. Okay? Or you could say that voltmeter is actually over that lot there. Gives you the same reading. I guarantee if I had to put a voltmeter over there, it would read the same as that voltmeter over there. Okay, so if you see a voltmeter drawn like that, it's not a problem. Right, let's have a look at number 17. What's the voltage of the battery there? Has it been given to you? No. What's the voltage on the on the 6 ohm resistor? 9 volts. Well, then obviously we add that voltage and that voltage, it will give us the battery's voltage. So what's the voltage over the 2 ohm resistor? Well, you don't know yet, do you? It's not given to you directly. Dylan, how did you get it? 6 ohms, the resistance there on the left, is 3 times bigger than the 2 ohms. Therefore, that must be getting 3 times more voltage than this one. So if that's getting 9, what must V3 be? 3 volts. Okay, all happy with that? And therefore, what must the battery be, Luto? 12 volts. Will you do number 18, please? Is there anyone who's struggling with this? Because then I'll come and help you now. Everyone happy? Yes. No, it's all there. Right, let's do number 18. Who's been struggling a little bit and we can do it with them? No one. Okay, who'd like to do number 18? Okay, Nikita, where would you start? So you're starting at the 2 voltages. Okay, what do you notice about the 2 voltages, V2 and V3? This one over here is getting 3 times more energy than this one. Okay, so what does that tell you? Which is the bigger resistor? The 18 ohms is how many times more difficult than this one? 3 times. So if that's 18 ohms, what must that resistance be? 6 ohms. Okay. What's my battery voltage going to be? 8 volts. All happy? Battery 8 volts and the unknown resistor is 6 ohms. Right. Number 19, please. Notice how we do the battery over here like we did the other day. That could be 20 cells, it could be 2 cells, doesn't matter. Okay, you've just got a battery there. Right, let's have a look at number 19. Has everyone finished number 19? Okay. Who'd like to do this one? Okay, Jock, where do you want to start here? Of the resistor, we've got 3 resistors here. This one. You want to try and find out that resistance. How are you going to do it? So you're going to look at V1 and V2. This one's getting 3 volts, this one's getting 9 volts. Which one is the more difficult resistor to get through? That's the bigger resistor. How much times more difficult is it? So what would this resistance be? Everyone happy that that's 6 ohms? Okay, right. Who's doing the next part of this sum? Come on, people, don't be scared. Please volunteer. Yes, Alberto? Have a look at that and that. 8 is 4 times bigger resistor than the 2 ohm resistor. So it must get more or less. How many times more energy? So if that's getting 3, this would get 12 volts. Right, are we happy with that? Okay, if I had said, what's the voltmeter reading over the battery going to be? It would be 3 plus 9 plus 12 equals 24 volts. Everyone happy with that? Good. Are you all understanding this? You notice you haven't used a single formula yet. You can do all of these calculations without formulas. I rather that you don't use a formula. You're going to start using a formula where you'll just say V equals IR, will be easy. But if you can understand it this way, electricity literally becomes baby stuff, and you all get full marks for it. Okay, so it's simple, straightforward. If I'd given you a circuit like this 3 lessons ago, you would have all been panicking. Now you're busy working out ratio and proportion between voltmeters and ammeters and resistors and so forth. It's simple stuff. Homework is number 20. Okay, some of you maybe finished it already. Before you start packing away, you'll notice that all the resistors we've dealt with here are in what? Series. When we start putting the resistors in parallel, slightly different. Actually a lot easier. Okay? So we'll worry about that tomorrow, but today we looked about voltage over resistors in series. Tomorrow we're going to look at voltage over resistance in parallel. Thank you. That's the end of today's lesson.